Look up at the night sky on a clear evening. The vast expanse above is dotted with countless stars, each one a tiny beacon of light in the immense darkness. Thousands of stars twinkle back at you, creating a mesmerizing tapestry that has fascinated humanity for millennia. These stars, though appearing static to the naked eye, are part of a dynamic and ever-changing universe. Each one a distant sun, perhaps with planets of its own. These celestial bodies are not just isolated points of light. They are part of complex systems, with planets, moons, and other objects orbiting them. But what you might not realize is that most of these stars are part of a massive structure called the Milky Way, our home galaxy. The Milky Way is a sprawling collection of stars, gas, and dust, bound together by gravity. And the Milky Way, along with nearly every other galaxy in the universe, is moving away from us. This movement is not random but part of a grand cosmic dance, driven by the expansion of the universe itself. This isn't because we've done anything to offend the cosmos, it's a natural consequence of the universe's expansion, a process that has been ongoing since the Big Bang. It's simply a consequence of the way the universe is expanding. Imagine the universe as a balloon being inflated. As it expands, every point on the surface moves away from every other point. Think of it like baking a loaf of raisin bread. As the dough rises, the raisins representing galaxies all move farther apart from one another. This analogy helps us visualize the concept of cosmic expansion. As the dough rises, the raisins representing galaxies all move farther apart from one another. This simple yet powerful analogy illustrates how galaxies drift apart as the universe expands. This expansion of the universe is a fundamental aspect of cosmology, the study of the universe's origin and evolution. Cosmologists use this knowledge to understand the past, present, and future of the cosmos. It's one of the most profound discoveries in the history of science, and it has revolutionized our understanding of our place in the cosmos. The realization that the universe is expanding has led to new theories and models that explain the very fabric of reality. The discovery of the expanding universe was made possible by the work of many brilliant scientists, including Edwin Hubble, whose observations of distant galaxies provided the first evidence of this cosmic phenomenon. The concept of an expanding universe also ties back to the Big Bang theory, which posits that the universe began as a singularity and has been expanding ever since. This theory has been supported by a wealth of observational data. One of the key pieces of evidence for the Big Bang and the expanding universe is the cosmic microwave background radiation, the afterglow of the Big Bang, which permeates the entire universe. Modern cosmologists continue to study the expansion of the universe, using advanced telescopes and computer simulations to probe deeper into the mysteries of the cosmos. Their work helps us understand not only how the universe is expanding but also why it is doing so. One of the most intriguing aspects of the expanding universe is the role of dark energy, a mysterious force that seems to be driving the acceleration of the universe's expansion. Understanding dark energy is one of the biggest challenges in modern cosmology. As we look to the future, the universe will continue to expand, with galaxies drifting further and further apart. This ongoing expansion will shape the ultimate fate of the cosmos, a topic that continues to captivate scientists and laypeople alike. So the next time you gaze up at the night sky, remember that you are witnessing a universe in motion, a cosmos that is constantly evolving and expanding, carrying with it the secrets of its past and the promise of its future. Now, here's where things get even more interesting. Astronomers have observed that the farther away a galaxy is from us, the faster it appears to be moving away. This relationship between distance and speed is a key piece of evidence for the Big Bang theory, which describes the universe's explosive birth. This observation has led to some mind-bending implications. If the universe is expanding, and the expansion is accelerating, then there must be some galaxies out there that are moving away from us faster than the speed of light, right? This is where our intuition about speed and motion might lead us astray. We've all grown up learning that the speed of light is the ultimate speed limit in the universe. Nothing can travel faster than light, according to Einstein's theory of special relativity. So, how can we reconcile this seemingly contradictory idea of galaxies moving faster than light? The key lies in understanding that the speed of light is a limit for objects traveling through space. However, the expansion of space itself is not bound by this limit. It's like imagining ants crawling on a balloon as it inflates. The ants can only crawl so fast, but the balloon itself can expand at any rate. If two ants are far enough apart, The expanding balloon could carry them away from each other faster than either ant could crawl. Section 4. The speed of light. A limit on information. The speed of light is often referred to as the cosmic speed limit, but it's important to understand what this means. When we talk about the speed of light, we're referring to the speed at which light travels in a vacuum, which is approximately 299,792 kilometers per second, or about 186,282 miles per second. This speed is not just a random number, it has profound implications for the nature of our universe. The speed of light is not simply a limit on how fast objects can move through space, it's a fundamental constant of nature, woven into the very fabric of the universe. This speed limit is a consequence of the structure of space and time itself, as described by Einstein's theory of relativity. According to this theory, as objects move faster and faster, they require more and more energy to continue accelerating. At the speed of light, an infinite amount of energy would be required, making it impossible for any object with mass to reach or exceed this speed. It's a limit on the speed at which information can travel. This means that no signal, no matter how it is transmitted, can travel faster than the speed of light. This has profound implications for our understanding of causality and the nature of the universe. For example, it means that events that are separated by large distances cannot influence each other instantaneously. There is always a delay, determined by the distance between the events and the speed of light. This means that nothing, not even light itself, can travel faster than the speed of light through space. This speed limit applies to all forms of electromagnetic radiation, including radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. It also applies to gravitational waves, which are ripples in the fabric of space-time caused by the acceleration of massive objects. However, the expansion of the universe does not involve the transmission of information. The universe is expanding, and this expansion is causing galaxies to move away from each other. But this movement is not due to the galaxies traveling through space. Rather, it is due to the space between the galaxies expanding. This expansion can occur at a rate that exceeds the speed of light, but it does not violate the cosmic speed limit because it is the space itself that is expanding, not the objects within it. It's a stretching of space itself, and this stretching is not subject to the same limitations as the movement of objects through space. Imagine the universe as a balloon with dots on its surface representing galaxies. As the balloon inflates, the dots move away from each other, not because they are moving on the surface of the balloon, but because the surface of the balloon itself is expanding. This analogy helps to illustrate why the expansion of the universe can exceed the speed of light without violating the cosmic speed limit. Think of it this way. If you were to shine a beam of light from Earth to a galaxy that is moving away from us faster than the speed of light, the light would never reach that galaxy. This is because the space between us and that galaxy is expanding faster than the light can travel through it. The light would be effectively stretched, along with the expanding space, never closing the gap between us and the distant galaxy. This is because the space between us and that galaxy is expanding faster than the light can travel through it. This phenomenon is a key aspect of our understanding of the universe's large-scale structure and its evolution over time. It also underscores the importance of the speed of light as a fundamental limit on the transmission of information and the interaction of distant objects in the cosmos. Section 5. The expanding universe. To understand how the expansion of space can lead to galaxies moving away from us faster than light, we need to delve a little deeper into the concept of the expanding universe. The universe is a vast, almost incomprehensible expanse that has been growing ever since the Big Bang. This expansion is not like an explosion where objects are flung outward into pre-existing space. Instead, space itself is stretching, carrying galaxies along with it. Imagine the universe as a giant sheet of rubber. This analogy helps us visualize how space can expand. Now imagine that this sheet is being stretched in all directions. As it stretches, every point on the sheet moves away from every other point. This is similar to how galaxies move away from each other in our universe. As the sheet stretches, the distance between any 2 points on the sheet increases. This is a crucial point to understand because it means that the farther apart 2 points are, the faster they will appear to be moving away from each other. Now imagine that there are galaxies scattered all over this sheet. Each galaxy is like a point on the rubber sheet. As the sheet stretches, the galaxies will also move farther apart from one another. This movement is not because the galaxies are traveling through space, but because the space between them is expanding. The farther apart two galaxies are, the faster they will appear to be moving away from each other. This is because the amount of space between them is increasing at a faster rate. The expansion of space is uniform, meaning it happens everywhere in the universe at the same time. However, the effect is more noticeable over larger distances. This stretching of space is what we mean by the expansion of the universe. It's a fundamental aspect of our cosmos that has profound implications for our understanding of the universe's past, present, and future. It's not that the galaxies themselves are moving through space faster than light. In fact, no object can travel through space faster than the speed of light. It's that the space between them is expanding, and this expansion is carrying the galaxies along with it. This concept helps us understand why we observe distant galaxies moving away from us at speeds that seem to exceed the speed of light. The universe's expansion is a fascinating and complex phenomenon that continues to intrigue and challenge scientists as they seek to unravel the mysteries of our cosmos.